So we started with this question of how complexity can arise out of something quite simple, and there's another way in which this can happen, and that is through chaos. Can you explain that a little further?
Yeah, we talked at the beginning about you've got this separation between laws of nature, which are rather simple, symmetrical, and the outcomes of the laws of nature. And for a long, long time, the educational process at schools and universities has very much focused on the world of the laws and simple solutions, things that you can do with pencil and paper in 30 minutes under examination conditions. But I think it was in the early 1980s that there was a significant change in the approach of scientists and mathematicians. And it was brought about by the IT revolution. That suddenly there were inexpensive, small desktop computers that didn't cost very much money, that were easy to use, and they had fast interactive graphics. Before that there were computers in science, but they cost millions of pounds, and they were controlled by huge research groups doing blockbusting problems like exploding bombs, studying supernovae, or trying to predict the economy or the weather. But all of a sudden, single individuals or small groups could study very complicated processes experimentally on the screen. So you might lay down some rules about how different types of particle interact with each other. They might be people, or they might be predator and prey and animals, and just watch what happened. And from the 1980s, early 1980s onwards, there grew up this study of chaotic and complex processes. So chaos was something that you found within many, many of these investigations. And chaos is just extreme sensitivity to ignorance. So you have a process where there's a little uncertainty in how it starts, but as you evolve to the future, that uncertainty grows dramatically, exponentially at each step. So we recognize many processes like this. The weather is like this, at least in the UK, where the reason we can't predict the weather very successfully a few days ahead is not because we don't understand the weather in some deep sense, that there is some mysterious weather force that we don't understand. It's simply that we don't know the state of the weather everywhere with sufficient accuracy to be able to predict the future infallibly. So we might measure the weather every 50 or 100 miles over the land, a bit further separated over the sea, and then you use a supercomputer to predict the future from that. But the uncertainty between the weather stations is sufficient that it grows dramatically as you run the computer, and you would end up with different weather forecasts according to how you interpolated between the weather stations. So uncertainty in the weather is a manifestation of our ignorance of the starting conditions, even though we know the laws of how the weather change very, very accurately.
So whether you find the world simple or complex depends on whether you're looking at the laws of nature or the outcomes.
Yeah, so if you're a particle physicist, gravitation physicist, you will spend a lot of time focusing on the laws of nature, how to extend them, how to express them, how to unify them. And for you, the world is preeminently actually rather simple. You're focused on the laws of nature. They are the truer reality for you. And for you, the laws have this Platonic appearance. They are simple and symmetrical. But if you're a life scientist, a biologist, an economist, or even someone working condensed matter physics or chemistry, you'll never talk about laws of nature. What biologist ever talks about the laws of physics? Because you're only interested in little bylaws and rules of thumb that happen in the complicated world of the outcomes that you spend your time trying to make sense of. You might be using game theory or studying stability, but for you the world is very complicated, and you have to use computational techniques to really get a handle on the most complicated things. So the world is both simple and complicated, and it's simple at the level of the laws of nature, the unseen laws, and it's complicated at the laws of the happenings, the events and the outcomes that arise from those laws.
Okay, thank you very much.